So we return now to computable general equilibrium models, and what I'm going to do is to introduce the Armington hypothesis, which is a very important assumptions of computable general equilibrium models. This assumptions responds to a specific problem. In the computable general equilibrium model that we built together concerning trade relations with the rest of the world, in each sector there were either only exports or only imports, but never in one sector did we have at the same time exports and imports. Well, this is not realistic. In all countries across the world, when we consider three sectors, agriculture, industry, services, there are exports and imports of this country with the rest of the world in each sector. Even when we consider a more disaggregated economy, there are simultaneously exports and imports. For example, at the International Food Policy Research Institute, when modeling a trade agreement, we use a computable general equilibrium model with around 30 sectors and 30 countries. And there are exports and imports in each sector in each country. So there is no one-way trade, but two-way trade. That is to say, exports and imports in each sector, in particular at an aggregated level like only three sectors. So for example, if you look at Kenya in 2017, if you look at the trade with the rest of the world, you have when considering agriculture and mining, industry and services, you have exports and imports in each of these three sectors. These are data based on the WITS database. So, intra-industry trade is a prominent phenomenon, even with a high level of sectoral disaggregation. Here, with Kenya, if we adopt a level of disaggregations of 16 sectors, for 2017 we still have two-way trade in each sector. In the previous model, in each sector we supposed that the local good and the foreign good were identical. So either the domestic country was more competitive than the foreign one, and it was exporting this good, or it was less and it was importing this good. And so with identical goods, there is one-way trade. To explain two-way trade, Paul Armington in 1969 supposed that internationally traded products are differentiated by country of origin. This is now what we call the Armington hypothesis. And so with this differentiation, even if they are not offered at the same price, consumers may be interested by buying all these goods. And so it means that competition is not only at the price level. And there are two consequences of this assumption. First, it implies two-way trade. So for example, French people buy French cars and German cars, and German people buy German cars and French cars, and so it means that there is exports and imports within the same sector. And the second consequence, which is also important, is that trade shocks are now much more realistic. Thus, we include in our model the Armington hypothesis. Products are differentiated by their country of origin. And in each sector, economic agents can buy products from all origins. And so it means that in each sector, there are simultaneously exports and imports. And the simplest way to assume product differentiation is to assume a constant elasticity of substitution function, or CES function. And what is important here is that we have only one parameter to estimate per sector, since this elasticity doesn't vary, and the other parameters can be calibrated. In each sector, the total local demand for good I is divided into local demand for the local good and local demand for the foreign good, that is to say imports. The local good can be substituted for the foreign good and vice versa. On one hand, in a sector, the intensity of this substitution when prices vary is always the same. And on the other hand, between two sectors, the elasticity of substitutions may be different, and this depends on the characteristics of the good in question. So, how do we model this? In fact, in each sector, the total local demand for the good I, local or foreign good, is also called absorption, and it has four components. First, the private final consumption of good I, CI. Second, the private intermediate consumption of good I by sector J, CI J, IJ. Third, the consumption of good I as capital goods, CKI. And finally, public consumption of good I, CGI. So I call dem tot I this total demand in volume. And so there are two options. Either it is assumed that households, companies, public sector have a different behavior when they substitute foreign goods for local goods or local goods for foreign goods. Or it is assumed that all agents have the same behavior, and in this case the same elasticity when they substitute foreign goods for local goods or local goods for foreign goods. And so we will adopt the second hypothesis. All agents have the same behavior, and in this case the same elasticity when they substitute foreign goods for local goods. So the CES function is at the level of dem tot and not at the level of each component of dem tot. And so we only need one elasticity by sector and not one for households, one for firms, one for the government. In fact, this is actually the problem because we do not have empirical evidence of elasticity by type of agent. So there are four equations which describe the Armington hypothesis in a CGE model like this one. So the first equation is determinations of total demand in volume. So total demand in volume is demand from households, private final consumption, plus intermediate consumption, plus consumption of goods for investment reason, plus public consumption. So the second equation is the total demand in value. That is to say, the total demand in volume dem tot multiplied by a composite price of total demand, P dem tot. It's the sum of the value of local demand for local goods in value, so PD multiplied by D, plus local demand for foreign goods, that is to say imports in value, PM multiplied by M. You can understand this equation as determinations of the composite price of total demand, P dem tot, which is a weighted average of PD and PM. And then you've got two equations for the determinations of D and M, that is to say for the determinations of local demand for local goods, D, and local demands for foreign goods, M. And this follows the same functional form. So it's D over composite total demand, dem tot, D over dem tot, which is a decreasing function of PD, or an increasing function of the ratio composite price of total demand over price of local good PD. And sigma arm is the elasticity, the Armington elasticity. And same thing for M over dem tot. It's an increasing functions of the ratio P dem tot over PM, with sigma arm the elasticity of substitution. Let's now look at the modeling of supply. In each sector, local producers sell a good, and they can sell it locally or they can export it. The conditions of sales are different, of course. For example, the foreign market price may differ from the local price. One could assume that producers sell all their production on the highest bidding market, but this does not correspond to reality. Even with different prices, producers sell their production on all markets. What is the explanation? It may be related to a cost they incur if they have to reallocate their production from one market to the other. To model this, we will use a CET function, or a constant elasticity of transformation function. It is a function such that only one parameter needs to be estimated. So this is good because we do not have to do too much econometric estimation. Second, for a price level, producers allocate their total supply between local market and exports. And third, if there is a price variation, there is a variance of this allocation in favor of the market whose price increases. Therefore, if the ratio domestic price of a foreign price increases, the ratio local sales of exports increases. So with CET, the local supply of good I is either a local supply of good I on the local market, or a local supply of good I on the foreign market, that is to say exports. We are going to have a functional form that looks like the CES, but here it concerns supply and not demand. For a specific sector, the elasticity of transformation is constant. This elasticity measures the intensity with which producers reallocate their production from one market to another when prices change. So this intensity is constant in a specific sector. But this parameter of elasticity may vary from one sector to another or from one country to another. With a good that will be expensive to reallocate from one market to another, we can imagine that the ratio of local sales of exports will react little to a change in the domestic foreign price ratio. On the contrary, with the good that it is inexpensive to reallocate from one market to another, this ratio will vary greatly. So let's present the equation, but first we have to present the annotation. So let yi be the total supply, pyi the supply composite price, pdi the local sales price, pxi the export price, xdi the local sales, and xi the exports. So let's present now the equation for the modeling of supplies with the CET. So there are three equations, and they look like a CES, but it's a CET, and it is on the supply side. So first equation, it's PYY is equal to PXX plus PDXD. So total value of production is equal to total value of export plus total value of domestic sales. You can understand this equation as determinations of the composite price of supply, PY, which is an average of PX and PD. And then you've got two equations for the determinations of X and XD. First, concerning X, it's X over Y, that is to say exports in volume over production in volume, is an increasing function of Px over Py, with sigma CET the elasticity of transformation. It's an isoelastic functional form. And the second one is XD over Y, that is to say domestic sales over production in volume, is an increasing function of PD over Py. As far as indirect taxation is concerned, all goods sold locally are subject to an indirect tax. So if we call indirect underscore tax in sector I the indirect tax rate, and P in sector I the consumer price, we've got the relation. So P dem tot, which is the composite price of total demand, multiplied by 1 plus the indirect underscore tax, which is the indirect tax rate, is equal to the consumer price PI. So it means that there is no assumption of different indirect taxation depending on who buys, either the households or the company, the government, they all pay the same tax. Imported goods are subject to a customs duty. If TM in sector I is the customs duty and PWM in sector I the world price of good I, E is the exchange rate, we've got the relation PM is equal to E multiplied by PWM in sector I multiplied by 1 plus TM in sector I, where PM in sector I is the local price of foreign goods or local price of imports. We do not suppose a fiscality on exports, so here the relations is very simple. Px in sector I is equal to E multiplied by Pwx in sector I, which means that the local price of exports is equal to the world price of exports multiplied by the exchange rate. We make a large country assumption, which means that this country has an influence on world prices on the import side and on the export side. So it can be criticized on the basis that the country that we study is small, but in this case we will choose an elasticity that reflects this. So in fact it is a more general form, and so we keep the large country assumption for both the import side and the export side. On the import side, supply of imports by the rest of the world is the equation M in sector I is equal to Fm in sector I multiplied by Pwm in sector I at the power sigma m in sector I. So you can understand this relation as the fact that if the rest of the world is ready to increase its supply of imports to this country, it has to be paid more, so PWM has to increase. Or you can also understand that if this country reduces its imports, it means that the world price of these imports will decrease. On the export side, the relation is describe the demand for exports by the rest of the world. So it is written X in sector I is equal to a constant which is Fx in sector I multiplied by the world price Pwx in sector I at the power minus sigma x in sector I. And so you can understand why this is a decreasing function between x and Pwx by saying that in fact the rest of the world is ready to increase its demand for these products exported by this country if the price of this good is reduced, okay? Or you can understand that if this country reduces its exports by either a taxation or a prohibition, it will have, in fact, an increasing impact on the world price. So let's describe the rest of the model. We've got a new equilibrium, market equilibrium. It's the equilibrium on the market for local good. And so it is an equation which is xd in sector I is equal to d in sector I. That is to say, the supply of local good on the local market, xd, is equal to the local demand for local good, d in sector I. There is also a new way of writing the foreign trade sold, because in fact this balance now is simply exports minus imports. So it's in fact the exchange rate E multiplied by the sum over I of exports in value at world prices minus imports in value at world prices. Concerning the public balance, you have to keep in mind that on the revenue side you've got direct taxation ITR multiplied by INC. Then you've got indirect taxation, which is sum over I of indirect underscore tax I multiplied by P dem tot in sector I multiplied by dem tot in sector I, and the custom receipts, which is simply sum over I of exchange rate multiplied by the import duty TM in sector I multiplied by the world price PWM in sector I multiplied by M in sector I. On the expenses side, you simply have the value of these expenses, which is called budge underscore exp. Let me present the entire model, all the equations of the model. First, we have a price block with 3 equations. The first one being the relations between the composite price of total demand and the consumer price, the gap being the indirect taxation. Second, the relations between import price, local price of imports, and the world price of imports, the gap being the import duty. And then the equation relating the local price of exports to the world price of exports. Then you've got a block which is the large country assumption. That is to say, first we have demand for exports by the rest of the world and a supply of imports by the rest of the world. Then you have the production block, which is composed of 3 subsets. First subset, the Leontief at the first level. So there is a proportional relation in volume between value added and production. That is to say, between VA and Y. And there is a proportional relation in volume between total intermediate consumption, IC, and production, Y. And then you've got the total value of production, PY multiplied by Y, which is equal to the total value added, PVA-VA, plus the total value of intermediate consumption, PIC multiplied by IC. Then you've got a second subset, which is the Cobb-Douglas at the second level on the primary factors side. So first, the value added is a Cobb-Douglas of the demand for capital and demand for labor. And then you have the demand for capital, which is a constant share in value of the value added, and then the demand for labor, which is also a constant share in value of value added. And then you've got the Leontief at the second level. So first, the total value of intermediate consumption, PIC multiplied by IC, is equal to the sum over I of the intermediate consumption of good I by this sector. And then you've got the Leontief, strictly speaking, which is the proportional relation in volume between the intermediate consumption of good I by sector J and the total intermediate consumption of sector J. Then you have a block which describes the CET concerning the supply between local sales and exports. So first, the total value of production at sales price is equal to the total value of exports plus the total value of domestic sales. And then you have an equation determining the exports in volume and then the domestic sales in volume. Then you have a block which is the formation of income and its utilization. So first, the formation of income comes from the ownerships of primary factors, LS and KS. Then the disposable income, which is different from the income because there is a direct income tax. Then you've got savings, which is a proportions of disposable income. And then you've got the consumption in value of each sector, which is a constant share of the disposable income. And then you've got utility, which is a Cobb-Douglas function. Then you have a block which is the demand of good I for private investment, so it did not change as compared to the previous model. Then you have the public account. Let's note that on the revenue side, you've got direct taxation plus indirect taxations plus custom duties. And on the expenses side, you have got only one variable, which is the total public expenses in value. And then you have the distributions of these expenses between all sectors to determine the level of public demand in each sector in volume, CG in sector I. So it is as the public sector follows maximize the Cobb-Douglas utility function. And then you've got the block market equilibrium with equilibrium on the labor market, equilibrium on the capital market, and an equation that I already described, which is the local sales equal to the local demand for local goods. Let's note that the Léon variable has been put on on the labor market equilibrium. Then you have the absorption block, which is the determinations of total demand in sector I. This is private consumption by households, intermediate consumption, capital goods consumption, and public consumption. Then you have the Armington block with one equation, which is the total value of total demand, which is equal to total demand for local good plus total demand for imports. And then you've got an equations of determinations of the local demand for local goods and local demand for foreign goods. Then you've got the macroeconomic equilibrium block, which is of course saving minus investment plus public balance is equal to external balance. And then you've got the foreign trade sold, which is equal to exports in value minus imports in value. So here in the social accounting matrix, the big change comes from the fact that there are exports and imports in each sector. Let's start with exports. They are 350 in agriculture, 30 in industry, and 100 in services. So they are a new source of demand for local producers. Imports are 150 in agriculture, 430 in industry, and 90 in services. So it's an additional supply in addition to local production. And finally, it's necessary to pay attention to the state's revenue and the amounts of 150 in agriculture, 1,320 in industry, and 280 in services. So these amounts correspond to domestic indirect taxation, but also to customs revenue. So it's necessary to have this customs revenue available to deduct them from the total amount in order to have the revenue from indirect taxation. Let me mention that you have an Excel file on the website that is the social accounting matrix for this problem. You also need some parameters to build the model and to make the simulation. So here you've got first the initial collections of custom revenue in US dollar millions. So this is something that I have just explained. Then the elasticity of demand for exports with respect to world price, sigma x in sector I. Then the elasticity of supply of imports with respect to world price, which is called sigma m in sector I. You also need the elasticity of transformations of the CET, domestic sales versus exports, so it is sigma CET, and the elasticity of substitutions of the Armington, the CES, this is sigma underscore arm. So I'm going to present the calibration, but first there is the entry of data. So here it's data from the social accounting matrix, which is a table which here I call MCS. So remember that you've got access to the social accounting matrix on the website. So here these are the data that I enter. There are some modifications and I let you work on these modifications. It's easy to understand. You also have the possibility to make some normalizations of prices to 1. So here are the normalization that I would like to conduct. It's noteworthy that, in fact, you can not do normalizations of all prices of the model. For example, you have relations between PWM and PM, and so here I'm doing a normalizations of PM to 1, so I cannot make a normalizations of PWM to 1 because there is this relations in the model. It would not be consistent. Here is the calibration, which is, I think, the most difficult part of the program. So this is the reason why I'm giving you the entire calibration. But please do not only make a copy and paste here. I would like you to pay attention to the logic of this calibration. Remember the main principles of this calibration. First, you need to give a value to all parameters of the model, but also an initial value to all variables of the model. And so just after the calibrations, you will have to initialize the variables. Second, at the end of the calibration, once you will have initialized the variables, all equations must be verified. That is to say, for each equation, the left-hand side must be equal to the right-hand side. So it means that the model is well calibrated according to initial value of all variables. And third, there is a logical order for this calibration. So for example, to get a value for the income tax rate, which is ITR, it is here the amount of income tax that comes from the social accounting matrix divided by INC0, which is the initial value of the income. So you need to get a value for INC0. And so it means it's the reason why before giving a value for ITR, you need to give a value to INC0. So here is the second part of the calibration. Remember that you have to give a value to all parameters and an initial value to all variables of the model, but also that you must be sure that at the end of the calibrations, all equations are verified and there is a logical order for this calibration. And here is the third part of the calibration. So for illustration, here you see that I give a value to INV0 before giving a value to alpha underscore k, because for giving a value to alpha underscore k, I need a value for INV0. And same thing for gamma and U0. I need to give a value to gamma before giving a value to U0. So here at the end of the program, so just before defining the model, we can define the numeraire. Remember that there is one equation which is not independent, so I need to to make a variable constant in order to have one variable less. And here it is the local price of the agricultural good. Then the public closure, well, in fact, what's happening here is that I suppose that the public balance is constant. So it means that if there is variations in public revenues, you will have the public expenses that will vary in order to be sure that the public balance is constant. I can make another assumption, but this is here the assumption that I choose, and this is something that I will comment later on. And finally, the external closure. Here I decided to make the exchange rate constant, so it means that the trade balance is variable, and so this is something that I can change, but this is also my choice, and I will comment later on. So I would like you to build this model with, of course, the model, the definitions of equations, the initializations of variables, the calibration, the entry of data, and the end of the program. So, and I would like you to study the scenario, the following scenario. So what is the impact of unilateral removal of all import duties in this economy? That is to say, unilateral free trade. So it means that only this economy opens its borders. There is no another economy which open its borders to the product of this economy. So this is very specific. What is the impact on imports, exports, production, and final consumption in each sector? And also what is the impact on remunerations of labor and capitals and on national income? So I would like you to prepare a 10 slides PowerPoint to explain the result. Thank you very much.